Hi, my name's Alexander Craig. I'm delighted you've joined me for a full demonstration of the WingtraOne Gen II drone. The WingtraOne is a drone that's been designed purposefully for efficiency, accuracy and ease of use. I'm going to take you through an entire user workflow that's drone setup, flight plan creation and a full data mapping project. This is the workflow that's meant that users can collect a lot of data in a very short amount of time while still relying on high quality data for every single project. To do this, we've come to one of the largest quarries in Switzerland. This is a perfect site for a typical Wingtra user because of its constantly changing environment. A Wingtra user can expect to do stockpile reporting, planning, as-built surveying, environmental management, and all sorts of other use cases with the WingtraOne at a site like this. Using the WingtraOne at a site like this, a user can expect to save thousands in cost savings and man hours every year. So to do this project, I've brought a WingtraOne Gen II equipped with our flagship high-resolution RGB 61 camera. However, there are multiple other cameras that you can get for the WingtraOne Gen II for different types of projects and different types of purposes. In total, we have 4 swappable payloads which are functional in any of our WingtraOne Gen II drones. First, we have our flagship Sony RGB 61 camera. This is our most efficient Sony RGB payload and is ideal for high accurate data collection. We also have our Alpha 6100, which is an entry-level RGB payload. Then we have our Sony oblique camera. This has a tilted wide-angle lens that is ideal for 3D mapping. And finally, we have the Red Edge P camera. This is a multispectral payload that captures data across 5 bands plus a panchromatic sensor to gather data for RGB outputs. So the first thing I need to do is I need to set up the drone, place it on its takeoff and landing point. So I'm going to get the drone out of its portable bag. And the only thing I need to do to set up the body of this drone is just insert the middle stand. Just like that. So now what I'm going to do is I'm going to insert some of our lithium-ion batteries into the drone to give it some life. There are 2 batteries that come with the WingtraOne Gen II. Both of these are lithium-ion batteries and they both have 2 cables. So the main cable is a power cable which feeds voltage and power to the drone whilst it's flying, and the second cable is an SBS cable, or a smart battery cable as we call it. This feeds the drone with information about the condition of the battery whilst it's flying. So now that I've powered up the drone is making as many satellite connections as it can, and it's also running some background safety checks so that it's able to take off. So what I need to do is, I need to get the tablet, I need to make a flight plan. So first I'm going to insert the telemetry, and when I do this, the tablet is going to communicate with the drone. So since I powered the drone up, it's been looking for its sister telemetry connection. So the first thing I do is I go to the flight plan project page. So in this page, I have all of my flight plans from previous flights stored, and I can go into any of those at any time. But I want to create a new one from scratch for you guys today. So I'm going to select new. Now I need to give the flight plan a title. Let's call it Demo, nice and simple. Press next, skip KML import for this. And so now we're brought directly to the flight plan project screen. So you can see on here, the drone in orange here is automatically located because the drone is already connected to satellites and it knows exactly where it is, and it's telling us on the screen where it is. So let's zoom out a bit. So the first thing I should do is I should insert a home point. A home point is basically the section of the flight plan whereby we're telling the drone which direction to take off in and which height to take off in. So you can see as soon as I selected that, the home point was automatically inserted and it's transitioning in a northern direction. Now, if I want to, I can move this direction with this simple slider so that it can take off in a direction that suits me best. I can also change the transition height for this. So it's set automatically as a default as 50 meters, but I can set it as 100, I can set it as 40, or I can set it as 60. Today it's quite a hilly environment, so I'm going to set it at 60 meters just to make sure it clears all the obstacles in the area. So next, the most important thing, I need to insert an area. So this is the point where I'm telling the drone exactly where I want to capture data. So you can see this little area box has automatically jumped onto the screen. So I'm just going to pull these indicators to cover the entire site that I'm going to map. So that's the area set. You can see on the screen the highlighted orange area. This is basically the area for which the drone will be collecting data. That's where it knows it needs to take images of, and your final map will be a map of that area. So you can see on the right hand side here, there are some parameters for this flight area. Automatically, the flight height is set to 120 meters above the ground, which translate directly to 1.9 centimeters per pixel of ground resolution in the final output map. If you've got a specific resolution that you need for your project, you can just change this and it will automatically change the height of the drone that needs to be to capture data at that resolution. So for example, if I need to capture data at 1.5 centimeters per pixel, you'll see the flight height above ground has changed to 95 meters. But today, let's go for 1.9, so it will fly at 120 meters above the ground. To make the flight a bit more efficient, I'm going to change the flight direction so that the sweeps are just a little bit longer. And that's it. I'm happy with my side overlap. I'm happy with my front overlap. I feel like I'm good to go here. So now what I need to do is I need to go to the safety checklist just before the flight. So I'm happy with the flight, what's going to happen. I need to go for a safety checklist before we take off. You'll see that there are a number of checks on this checklist that are already green. This means that these are automatic safety checks that the drone has already done for you, so you don't need to worry about them. I can just discuss a few of these for you here. So there's a connection to WingtraOne check, number 3. That's making sure we've got a telemetry connection. Number 4 is a power check to make sure the batteries are safe and sound. If there's a problem with the batteries, if they're too old or if they're too hot or too cold, at this point the tablet would warn us of that and it wouldn't be safe for flying. There's a GPS check to make sure it's got all of the, it's connected to enough satellites. But I'm going to go through the white ones, and the white ones are the ones that we need to do ourselves manually. So the first one is number 2. This is a hardware check. So to do this, I need to check a few things on the drone manually to make sure they're good for flying. So let's go and do that right now. So the first thing I need to do is a distance sensor check. This is just to make sure it's clean. And to do that, I just need to take a look at it at the bottom here. Yep, looks clean to me. And I need to do a propeller check. So this is just to make sure that the propellers are tightened properly, which unless there's been some heavy movement of the drone or some manipulation, they should be anyway after each flight. Yep, they look good to me. And of course, it's to take the lens cap off. That's taking the lens cap off is something you want to do for every single flight, but don't worry, there's a check that also checks to see if there's a lens cap on anyway. So I'm confident that that safety check was done properly and the equipment is good. So I just select number 2 and it turns green. So let's go down to the next check. Just before we go on to check 12, you'll see check number 8 is a camera check. So I'm going to press this one again just to show you guys exactly what's happening here. So when I select the camera check, it's going to redo the check for me. And what the camera is doing here, it's taking an image right now, and then the onboard computer is going to check the settings of that image to make sure that the settings are good enough to collect the high quality data that you need. The purpose of this check is to make sure that you're not performing an entire flight without a functioning camera that can collect images that you need for your data. It's going to take a few minutes to run this check and check the camera. This is also the check that would tell you if the lens cap is still on. So if the lens cap was still on, when it checks the image, it would notice that it's completely black, and this check would inform me that the lens cap is on. But of course, this check was green because it was a check that the drone had automatically done as soon as I powered it up. And when I was talking to you about creating the flight plan, the drone was already doing this beforehand anyway. So you see now the check has gone green because it's passed the camera check again. So next, check 12, this is to review and upload the flight plan. So this is for me to tell the drone exactly where it needs to fly and where it needs to capture data. So I select number 12, and you can see it's automatically uploading the flight plan. It gives you a nice percentage bar to let you know how long it'll take. No matter how large the project, never really usually takes longer than 20 or 30 seconds. The next check, check number 13, is a flap check. So when I select this, the flaps, the servos, are going to rotate to make sure there's nothing blocking the gearing system. This is a flight critical component of the WingtraOne, which is why we check it before every flight. That check's gone green as well. At this point, the check would inform us that there was a problem with the flap check, and at that point you can restart the flap check again or call support if there's a significant issue with the flaps. So now we've got check number 14, fit to operate. Please can you confirm that you're physically and mentally fit to perform this flight? Yes, I've done thousands of these flights. I'm very confident that I'm fit to perform this, so I just select that yes. Check number 15, the final check is check that there are no people closer than 5 meters to the WingtraOne. Ensure appropriate weather conditions and airspace. Yep, there's nothing else in my airspace, there's no one else around me. Click check number 15. The checklist is good, the drone's ready to fly. Now I just select play, swipe to confirm, and the drone will take off.
Forward transition.
So the drone is almost halfway through its flight now. I'm just going to take this opportunity just to show you a couple of the indicators that are on the WingtraPilot screen so you just know what's going on, so you're not completely in the dark here. There's a few things. For example, you can see that at the top it says 186 meters. Now you might remember that our flight plan was set at 120 meters above the ground. It's reading 185 meters, 186 meters, because this is the flight height above the home point. So whilst the drone is flying 120 meters above the ground, it's flying 180 meters above us, because the ground over there where it's flying is much higher than where we are. And when I select that, you'll see there are a number of different indicators and values showing us the WingtraOne status. For example, we've got the distance from home, which is telling us it's currently at around 1 kilometer, 1,000 meters. We've got the altitude above mean sea level, so it's at 797 meters above sea level. Importantly as well for our consideration, it's also got the wind speed indicator here. So the drone is constantly taking measurements of the wind speed, and we can see that it's reading at 5.6 meters per second. This is quite a low wind speed, it's nothing to worry about. If the wind speed does reach 12 meters per second, the drone will return to home automatically, because collecting data anything above 12 meters per second does not lead to accurate and valuable data collection. You can also see how many satellites it's connected to as well. We've also got the battery indicator here, so we can see the battery status. The voltage is currently at 29.81 volts. And we've got the left and right battery health status reading. So remember I spoke about the SBS cables. Those are telling the drone about the health of the cells in the battery. They're both good on this one. Along the bottom here, we've got a whole bunch of other values. So you can see it says 21 minutes and 56 seconds. So that time is an estimate for how long the entire mission would take. So as soon, if you go back to earlier in the video when I was making the flight plan, when I inserted the area into this flight, the estimation would have come up for 21 minutes and 56 seconds. So that's just so you just have a rough idea of how long it's going to take. There's also a little camera icon, and that shows 422. So that's just an estimate for how many images are going to be taken during the flight. These are not major things to be worried about or to consider. It's just useful information for you as a user whilst you're flying.
Please do not power off your WingtraOne while the flight data is being prepared on the camera SD card.
So that was a full flight with a WingtraOne, and a fully hands-off experience for me. The drone flew and landed completely automatically. So what's happening now is it's turned the propellers off, so it's safe to approach. And now on the tablet screen, what you might be able to see is there's another safety check where the drone is checking to make sure that the data that was captured during the flight is all of the data that it requires for this project. So it's making sure that the images and the coordinate data have been stored on the camera SD card. And as you can see, that check is complete. So I just need to dismiss this. It's turned green. And now I can unplug the telemetry and go and collect my data and turn off the drone. So I've unpowered the drone, so it's safe to pack away again. And now I'm just going to remove the camera SD card just to show you. So here's the camera SD card. This contains all of the data that you need for your workflow. This contains the images and the coordinate information that was collected by the drone during the flight. The only thing you need to do now is you need to drop this data and this information into any third-party photogrammetry platform to produce your maps and your projects. Now, I said in the beginning of this demonstration that there are many, many use cases for the WingtraOne Gen II. If you'd like more information on those use cases or all of the solutions that the WingtraOne accommodates for, then please don't hesitate to access our website at www.wingtra.com, where we have lots and lots of case studies and solutions information. Finally, I'd like to thank you for joining me today. It's been a real pleasure just to show you how simple and accessible this workflow is with the WingtraOne, and we very much look forward to hearing from you in the future. Thank you. So now let's take a deeper dive into what this intelligent WingtraOne Gen II system is capable of. Over the next few minutes, I'll demonstrate some of the features that mean that you're going to have stress-free flying for every single project. I'll show you low battery return to home, resume flight missions, battery health status warnings, and polygonal geofence creation. So in this failsafe feature, we're demonstrating the low battery return to home failsafe. Of course, some of you might be conducting missions that fly over such large areas that the missions themselves might last longer than 1, 2, or 3 hours. If the battery during these missions gets too low, you don't need to worry about it. The drone will make a calculation of how much battery it needs left to return to home, and it will automatically return when it's necessary. For example, this mission that you see on the screen here, when we set off with batteries that were not at full capacity. So even though it's only a 53-minute mission, it's unlikely that the drone will finish the mission before the batteries run out. As a consequence, when it's necessary, the drone will automatically return to the home point. So this drone has returned from a flight early because the battery became too low whilst it was flying and it wasn't safe to fly anymore. Now, the problem for us is that we've not finished our mission yet. So thankfully, there's a resume flight mission feature, which allows us to insert new batteries into the drone after it's landed midway through a mission and take off again to resume the flight in the same place. So that's what we're going to do now. So now that I've inserted some new batteries into the drone, I just need to go through the full flight checklist again and press play, and the drone will take off and fly. So now that the checklist is complete again, we're ready to fly. And we can see that there are some different things about this flight. In the top right hand corner, it's the same flight plan title that we had before, but it says Flight 2 now. That's because this is the second flight that we're conducting for this mission. You can also see on the map, there's a little play resume button just here. This is the point at which the drone will resume the mission and continue to capture data. It already knows it's captured images up to this point, and when it takes off and flies, it will go straight back to this point to save you time, so it doesn't need to conduct the entire mission again. So now we're ready to go. We just need to press play and swipe to take off. On the topic of batteries, as with most modern tech, these are the tech components which are most likely to suffer from wear and tear and become obsolete. As a consequence, with the WingtraOne Gen II, we've developed a feature whereby when the batteries start to get too old, after many uses, you'll receive a warning on your tablet about them getting too old, and you'll be recommended to buy some new ones. So to demonstrate this for you today, I've got 2 batteries here which I know are very old, have been used a lot. I'm going to insert them into the WingtraOne. When it powers up on the tablet, we should get a warning. And there we have it. I inserted the telemetry a few seconds ago, and already there's a pop-up warning saying battery replacement recommended. The right battery with the serial number 1121037581 is getting old. You can still fly for now, but eventually this will block takeoff. Contact us in order to order a replacement as soon as possible. So there we have it. The drone has informed us that one of the batteries is getting quite old. I can still fly with this, but eventually the drone will stop me from flying. And if I click on the battery indicator at the top there, we can see just here that the left battery is listed as good, and the right battery, the green side, the battery health is listed as a warning. For this feature, I'll demonstrate the polygonal geofence creation. All of us are aware of the dangers of flying drones, and rightly so. The regulations around the world are becoming tighter to account for this. In some cases, you might be performing missions near sensitive sites that either you don't have the permission to fly over, or you would like to ensure the drone doesn't go anywhere near them anyway. To help you here, we've developed an in-app feature that allows you to specifically define your flight window geofence, meaning you can define which areas of your map you would not like your drone to fly over under any circumstances. Like this. Now that I have excluded this building from my flight area, the drone will automatically turn around and return to home if it approaches this area. So today we've really only been able to touch the tip of the iceberg for all of the features and fail-safes that this intelligent WingtraOne Gen II system has. Some other ones include high wind speed return to home, whereby if the wind speed reaches above 12 meters per second, the drone will automatically return to its home point. There's also a in-app camera setting whereby you can change, depending on what the light settings and the light conditions are outside, you can change the settings of the camera internally in the app. There's a custom elevation data import, so if you're flying in terrain which changes quite often, you can import custom elevation data into your Wingtra pilot, so your WingtraOne definitely knows the elevation for the area it's flying in. And there's also things like offline map import, so if you're going to go and fly in an area that doesn't have an internet connection, then you can download the maps into your Wingtra pilot before going there, so you can perform your flight without an internet connection. Those are just some more of the many features and fail-safes that we have on this intelligent system. If you're interested in finding out more about the others, then I encourage you to contact sales@wingtra.com, where you can speak directly to an expert in your area, or go onto our website www.wingtra.com to find out more. Thank you very much.